Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Momen Mahgoub Ahmed, and I'm recharged for part A. Part A is required from us to make a full summary of the giving data. And first thing I did is count the shift, and the highest number of shift here, as we can see, is at the evening, which is 78, and morning is 57, night is 65, and in the ground total is 200. Next thing I did is the sum of weight, and at the evening is 27,000, and at night is 20,000. I mean, at morning is 20,000, at night is 22,000. So the grand total is 70,000, 70,001. For the sum of tensile strength, the total is 1,419. And also we have the relative density is 17,004. And also I calculated the average, also evening, morning, and night for the weight and tensile strength and relative density. The next thing I did is also calculating the value at risk for the weight, the tensile strength, and the relative density. Next thing is the maximum of weight, and the minimum, and the variation for each shift. And the last thing is making the graph for the weight, and making graph also for the tensile strength and the relative density. Thank you.
Assalamu alaikum warahmatullah. It's Mahmoud Khedr, and for part B, the Food and Drug Administration FDA Authority requires that weights of standard tablets produced by manufacturers should be normally distributed with 350 milligrams and with standard deviation of 14 milligrams. So present the required analysis and comment whether there is significant evidence that LjakLaku tablets produced in December 2021 do follow this distribution. So for the hypothesis, the normal distribution equals to 350 and the variance equals to 14 squared, and the n is the sample size. And for the hypothesis statement, let x represent the weight of standard tablets produced by manufacturers. So each node is weights of standard tablets produced by manufacturers do follow a normal distribution of 350 milligrams and variance of 14 milligrams squared. And H1 is the weights of standard tablets produced by manufacturers do not follow the normal distribution, which is 350 milligrams, and the variance, which is 14 milligrams squared. So for the frequency table, to do it, we will use the Excel. So in Excel, we have to go to data, then data analysis. But if you cannot find the data analysis here, you can just click here and then click add-ins, and then just choose this one, then click OK, you'll find it here. So click data analysis, then click histogram. So for the input range, we will select all the weight column, and for the bin range, we will select the bin column, which is the upper limits. Then click OK, then the frequency will come to you like here. Then we have the parameter of goodness of fit test. We have the weight, frequency, probability, and also the expected value. And here is the probability formula and expected value formula, and also the test statistic. We will set the significance level of alpha equals to 0.05, and since we have 6 categories, we will set k equals to 6 and p equals to 0. So you have the critical value equals 11.0705, and the x-test squared value equals 2.8177. So we will reject H naught if the x-test squared is larger than the critical value, which is 11.0705. And since the x-test squared is smaller than the critical value, so we will accept H naught. So in conclusion, there is good evidence that the LjakLaku tablets, tablet name pill LjakLaku I, follow the normal distribution that required by the Food and Drug Administration FDA authority, which is 350 milligrams with a standard deviation of 14 milligrams and variance 14 milligrams squared at alpha equals to 0.05.
Assalamu alaikum warahmatullahi wabarakatuh. I'm Mohamed Kamel from Group I. In Part C, we have been asked to check whether there any significant difference between tablet weights from different shifts. So we chose one-way ANOVA to perform our analysis. One-way ANOVA is the analysis of variance that allows us to compare several groups of observations with different mean for each group. Therefore, we sorted all shifts into 3 groups: morning, evening, and night shifts. We assumed alpha equal to 0.05, and our hypothesis is as following. H node is all means are equal, otherwise H1 is 2 of each means at least not equal. And here our result after using data analysis of Excel for each shift. As shown here, B value is 0.74, which is greater than alpha value. Finally, coming to decision rule, which is reject H node if B value is greater than alpha value. As a result, we fail to reject H node because B value is greater than alpha value. To sum up, there is no significant difference between tablet weights from the different shifts at alpha equals 0.05. Thanks for listening.
Assalamu alaikum warahmatullah. It's Osama Gamal from Group I. I'm going to continue with Part D. So in Part D, the question asks to protect the value of tensile strength of a given value of relative density. As we can see, there are 3 tables, our summary output. So from the regression statistic table, we can see that the linear relation is getting stronger in a positive direction. And that because the value of multiple R is almost 1. So we get 0.8. And the value of R squared is 0.703, which means around 70.3% of the data is suitable with the regression model. And here applying the hypothesis test, and here the hypothesis statement, and here test statistic. In the test statistic, the B critical value that we got from table 7, which is 0.84, is smaller than the B test that we get in ANOVA table, which is 467. So since the B test is greater than the B critical value, so we can say that H0 is rejected. And to get the value of protection of the tensile strength, we use the equation of the fitted linear regression. And here's the value that we used for omega and beta. So by plugging them in the equation and plug the value of the relative density, we get our protection. So as shown in the linear fit plot, that the value of relative density that given in the question are beyond the range, which is 83.3% and 94.7%. So it's obvious that the protection is invalid. And here's the graph that we got. The first one is the normal probability plot, as it can be shown in the statistic point. It's almost a straight line, so the normality of the tensile strength is satisfied. And the second plot is, which is the relative density plot. So as shown in the below graph, the points are randomly scattered along the x-axis, which means it's a good fitted linear regression model. And here the validity of the regression model. The first one, as shown in the normal probability plot, the normality of the tensile is satisfied. And the second one, the relative density plot, is a good fitted linear regression model. And the last one is ANOVA test. The linearity of the significantly exists between the tensile strength and the relative density at the significance level of 0.05. And that's all. Thank you.